Okay, so in our need to know section today, we're talking about one of the most important results of all, which is that tan theta is sine over cos. So I'm going to show you some examples today where this comes up, some easier ones and some more difficult ones. Let's go. So we're solving between 0 and 360, this one here. Okay, so knowing this result, a good step is going to be to divide both sides by cos theta when you have a mix of sine theta and cos theta. If we do this, we will get 3 tan theta equals 4. Solving for tan, okay, is an often sort of consequence of this one here. Tan theta equals 4 over 3 is now what we do. Before using arctan. Arctan, that means that's this sort of tan to the minus 1 to get rid of the step. Leaves us with theta equals 53.13. This is called your principal value. Okay, you're going to see some sketches of tan in a minute. The idea is that between minus 90 and 90, okay, we can observe all the values of the range, and your calculator, when it tries to work backwards like this, it will give you between this range here, so 53.13. That is in the domain that we want, so that's good. However, we are interested in sort of the next set of values as well. So our rule is going to be to add 180 degrees to get any other solutions, taking away sometimes as well. But here, adding on 180 gives us what? So 253, so 233.13 degrees. Two solutions in the domain is what we're looking for. Okay, so next up, we've got a similar situation with this one here. So we could move one to the other side and then do it, but it's not necessary. The idea is that you can sort of use these results whenever they're convenient. So I'm going to divide by cos theta straight away. And that would give me 2 tan theta plus just 3 equals 0. So the 0 makes this convenient. We do tan theta then equals minus 3 over 2. And based off our conversation a minute ago, okay, this result is going to lead to a negative answer. So when you do that on your calculator, you get minus 56.31 degrees. This is an issue because this doesn't match up with what I've asked for. So we need to be adding on 180 as many times as it takes to be comfortable that we've got all the solutions. So doing that, adding on 180 gives me 123.69 degrees and 303.69 degrees, and you could keep going to check, but that is going to do us for this part here. So let's try a more difficult result that benefits from tan being equivalent to sine over cos of the same input. So over here, okay, I've put in an example of something you might see in chapter 7 in year 13. So it says 2 sine theta plus 3 cos theta. And this question's guided us into making this, making it match this expression here. So this is a bit of an unusual one for a lot of people because of the way that you solve it. What we do is we write out our result of the addition rule, which would be r sine, let's do it like this, r sine theta. Sine is one, sine of the first one, cos of the other. So then this will be cos alpha. Okay, so that will be the first part of the addition rule. And then r again, I've sort of expanded the r's, if you like. If you imagine them being from here, I've sort of, expanded them. So it will be this. And now what's the next bit? I'm going to write cos of theta and sine of alpha. We've done it correctly if you've got those 4 unique pieces with a mix of sine and cos on each. Okay, so what we do is we write out the format we're going to express it in, and then we match this up with what we've already got, which is this bit here. So I'm just going to shuffle some pieces around and show you how we get these results here on the left-hand side. So just a bit of shuffling, because what I'd like to do now is I would like to write this part again. I'm going to write it as 2 sine theta. So just to make clear, I'm going to be expressing it in this format here. And over here, I'm going to do, what was it? 3 cos theta. So this is from the way that we want to express it. This is how it's expressed at the moment. Can you see then that we can get our results that by comparing, if you like, by comparing the sign bits, we can get this result and we can get this result. And that's really where tan can then come into things. By doing r sine alpha over r cos alpha, well, what's the missing number? This is a 3. We get 3 over 2, and we find ourselves with tan again. So tan comes up quite nicely when you have a mix of sine and cos, allowing you to do things like finding angles. Notice this angle here is in radians, 0.983. I've got that it rounds to. Reason why I'm using radians, okay, is based on clues elsewhere in the question. So that's how we do the first part, and it's very, very useful in answering the next part. So it's not a coincidence that I have the same part again, and now I have equal to 5 over 2. Just to sort of show you, it wouldn't work at this point if I divided everything just by cos straight away. I would have got 2 tan theta plus 3, yes, but I would have had a problem over here because this isn't a 0. I would have been doing 1 over cos theta, which is the same as sec theta. So this one here, okay, not especially useful. So instead, what we're doing is we're expressing this way from before, and now we're going to use the result. So instead of saying 2 sine theta plus 3 cos theta, I'm going to use what I found out. So I've got my alpha angle here. R can be shown to be root 13. It's always just the sort of square of each of these added together and rooted. Okay, but that's not really our focus for today. So if I put those results back in, I can say that this is root 13 sine of theta plus 0.983 equals 5 over 2. And then I can solve something much more difficult like this. Solving this one here. Okay, so solving this one here, how would we do that? Let's sort of say step 1, step 2. What we would do is we would divide by root 13. 5 over 2 root 13. We would do our inverse cos, so theta plus 0.983 equals, we get our values from this, okay? And then finally, at the end, we would just subtract that from each of our values. Okay, so it is one of our need to knows, and it's one of our need to knows for a reason that a lot of questions, whether they are simple solving with a mix of sine and cos, something more rearranged, or something more difficult in the course, often comes down to knowing that tan is sine over cos.